All right, let's finish up our discussion of obversion. Now remember, obversion has two steps. The first step is to change the quality but not the quantity of the statement that we're working with. So we started off with these two statements. All dogs are canines and some teachers are not fair graders. And to change the quality but not the quantity, we did this. We took this A statement, which is universal and affirmative, and we changed it to an E statement, which is also universal. So they have the same quantity, but it's negative. So they have different qualities. And for some teachers are not fair graders, we took that particular negative statement and we changed it to a particular affirmative statement. Some teachers are fair graders. Now, to complete obversion, all we have to do is replace these predicate terms with their term complement. So we ask ourselves, well, what's the term complement of canines? Is canines a kind of thing like possible actions and impossible actions, where I can identify a specific thing that is the opposite of canine? And I would suggest to you no, or at least not that I'm aware of. And when I don't know what the specific term complement for a term would be, I'm going to use my non. Okay, I'm going to use it really carefully, but I'm going to use it to create the statement, no dogs are non-canines. Now down here, I'm going to look at my predicate term, of fair graders, and I'm going to ask myself, is there another term that's similar to possible actions and impossible actions that I can use as the term complement for fair graders? You said unfair graders? You rock. Okay, yeah, so let's use that. Some teachers are unfair graders, okay? Now these statements are equivalent to the original statements we were working with. So these two steps of obversion allowed us to create two new statements that are different but communicate the exact same meaning. Okay? And this is true for all standard form categorical statements that we apply obversion to. When we obvert A, E, I, or O statements, the new statements are going to have the exact same truth values as the original statements. And we're going to obvert statements by doing these two steps, changing the quality but not the quantity, and then replacing the predicate term with its term complement. All right? Now guess what you get to do? You guessed it. You're going to practice applying obversion. This is super important because folks get really confused with obversion. So you want to take this opportunity to practice obversion and check your work. So you've got 4 statements up here on your screen. They're not in standard form. So that's the first thing you have to do is translate each one of these statements into standard form and then apply the operation of obversion to these statements. And when you're ready to check your work, you can unpause your video and we'll see what you got. All right, so let's see what you did here with these 4 statements. We'll just take them in order. So for the first one, we probably translate that as an A statement. All logic students are brainiacs. And when we obvert that, apply the 2 steps of obversion, we get no logic students are non-brainiacs. The second statement, we're going to get no logic students are troglodytes. And when we apply the 2 steps of obversion to that statement, we're going to get all logic students are non-troglodytes. Some logic students are crutivores. When we apply obversion to that, we're going to get some logic students are not non-crutivores. Now, I know that not non sounds kind of goofy, but remember the difference between not and non. Non is allowing us to identify a category of things, but not is creating negation. Not is denying. Okay, so they seem similar. It almost seems like you might be thinking to yourself, like, this sort of feels like a double negative, but that's not really true, because what this statement is saying is that there's some number of logic students that are excluded from this particular category of thing. All right, and finally, some logic students are not Gaberlunzies. The obversion is going to be some logic students are non-Gaberlunzies. Now, depending on the truth value of the original statement here, the obversion is going to have the same exact value. And we would say, oh, this statement, it's true by obversion. It's true because the original statement that I applied obversion to is true, so the new statement is true by obversion. Or the original statement was false, and so now this new statement that I've created is also false. All right, so how do I know that obverting any statement results in a new statement that has the same truth value as the original? Seems like a good question. How do we know that what I've just told you is true? Don't take my word for it. In the next lecture, I'll prove it to you.